Okay, we're now going to differentiate some products and quotients. So let's try with f of x equals x minus 2 bracket x plus 4. So first of all, I need to prepare to differentiate. So that'll be x squared plus 2x minus 8. I'm now in a position to differentiate, and that will be 2x plus 2, and the constant of minus 8 will go. Okay, let's try f of x equals x minus 7 bracket x plus 4. So again, first of all, prepare to differentiate first. That'll be x squared minus 3x minus 28. Can now differentiate that, and that'll be 2x minus 3. Okay, let's differentiate bracket 2x plus 1 bracket 3x minus 4. So that will be y equals 6x squared minus 8x plus 3x minus 4. I can now tidy that up. 6x squared minus 5x minus 4, and now differentiate. And that will be 12x minus 5. Okay, let's try differentiating x minus 4 all squared. So remember that that's just the bracket times the bracket, and expand that out, and that will give me x squared minus 8x plus 16. I can now differentiate, which will be 2x minus 8. Okay, let's try y equals x plus 1 bracket x minus 3 bracket x plus 4. Okay, so we've got a couple of different tactics for this one. Let's have the x plus 1 at the front multiplied by the expansion of that. So that will be x plus 1 bracket x squared plus x minus 12. I can now do that. So that will be y equals x cubed plus x squared minus 12x plus x squared plus x minus 12. Let's see if I can collect together terms here. So it'll be x cubed plus 2x squared minus 11x minus 12. I'm now ready to differentiate, which will be 3x squared plus 4x minus 11. Okay, let's try a couple that are a wee bit more complex. So we've got y equals the square root of x bracket x cubed plus the square root of x. So remember that whatever's in the bracket is multiplying what's outside the bracket. Okay, so first of all, let's change that root x to the x to the half using my rules of indices, and also do so in here. Okay, now remember that a to the power m multiplied by a to the power n is a to the power m plus n, so we add those powers. So that's 1/2 plus 3. So if you think about half a pizza plus 3 pizzas, that's a half plus 6 halves, that's 7 halves. So that's x to the power 7 over 2. And then let's add those together, 2 together. Half plus a half is x to the 1. So again, the root x changes to x to the half. When I multiply these together, I add the powers. So 1/2 plus 3 is 1/2 plus 6 halves, that's 7 halves, x to the power 7 over 2. And then 1/2 plus 1/2 is x to the power 1, which can just be written as x. I'm now ready to differentiate. So that's 7 halves x to the power 5 over 2. Since 7 over 2 take away 1 is 7 over 2 take away 2 over 2, which is 5 over 2. Then differentiate x, which becomes 1. I can now reintroduce the root symbol, and that will be 7 halves of the square root of x brought to the power 5 plus 1. Okay, so let's try f of x equals 1 over x plus 1 all squared. Okay, so remember that 1 over x can be written as x to the minus 1. So I can now write that as x to the minus 1 plus 1 all squared. Okay, so that's x to the minus 1 plus 1 bracket x to the minus 1 plus 1. Okay, so I can expand that out. I'm going to use FOIL method for that, but you can use another method. X to the minus 1 times x to the minus 1 is x to the minus 2 by using my first rule of indices. It's then outsides x to the minus 1 plus 1 is x to the minus 1. Insides 1 times x to the minus 1 is x to the minus 1 again. And then 1 times 1 is 1. I'm then going to just collect together like terms in the middle, so that'll be x to the minus 2 plus 2 lots of x to the minus 1 plus 1. I'm now in a position to differentiate, and that'll be minus 2x to the minus 3, minus 2x to the minus 2, and the constant vanishes. Okay, so I can now tidy that up, and that'll be minus 2 over x cubed minus 2 over x squared. Okay, let's try f of x equals 1 over x bracket 1 minus 1 over x. Okay, so that could be written as x to the minus 1 bracket 1 minus x to the minus 1. I can now expand that open, and that will be x to the minus 1 minus x to the minus 2, then differentiate. Minus 1x to the minus 2, minus 2 times minus 1 is plus 2x to the minus 3. Remember that there's a 1 in front there, so that's minus 1 over x squared plus 2 over x cubed. Okay, let's try another, which is f of x equals root x plus 1 over root x all squared. So that's x to the half plus 1 over x to the half all squared. I can now continue to prepare that. That'll be x to the half plus x to the minus 1/2 all squared. So x to the half plus x to the minus 1/2 bracket x to the half plus x to the minus 1/2. Okay, so using FOIL method, first x to the half times x to the half. Well, we're going to add the powers there, and that will be x to the 1, that's x. And then x to the half times x to the minus 1/2. So that's then x to the 0, which is equal to 1. Then x to the minus half times x to the half will give me 1 again. X to the minus half times x to the minus 1/2. Add the powers, and that will be x to the minus 1. Okay, so that's now x to the minus 1 plus x plus 2, and I can differentiate. And that will be minus 1x to the minus 2 plus 1, and 2 will vanish since that's a constant. I can now tidy it up, and it will be 1 over x squared plus 1. Okay, let's try another one involving division. F of x equals x squared minus 2x plus 1 over the square root of x. So that's x squared minus 2x plus 1 over x to the half. The strategy at this point should be to split the thing up, so x squared over x to the half minus 2x over x to the half plus 1 over x to the half. Okay, so for division, think about the rules of indices. We're going to subtract the powers, so 2 take away half. So think about 2 pizzas, take away half a pizza, that's 4 halves of a pizza, take away 1/2, that's 3 halves. Remember the power here is 1. So that's going to be 1/2. 1 take away 1/2 is 1/2. So that's minus 2x to the 1/2. And I'm going to bring that up and change its power. That will be x to the minus 1/2. I'm now in a position to differentiate, bring the power down, multiply, take 1 away from the power, 3/2 x to the, well, 3 over 2 take away 1 is 3 over 2 take away 2 over 2, which is 1 over 2, minus 1/2 times 2 is, that's going to be minus 1 x to the minus 1/2. Since 1/2 take away 1 is 1/2 take away 2/2, which is minus 1/2. And then minus 1/2 x to the minus 3 over 2. Since minus 1/2 take away 1 is minus 1/2 take away 2/2 is minus 3/2. Okay, I can now tidy this up. So that will be 3/2 of root x minus, bring that down, 1 over x to the 1/2 minus 1 over, and bring that down, minus 1 over 2x to the positive 3 over 2. I can now reintroduce the roots. So 3 over 2 root x minus 1 over the square root of x minus 1 over 2/8 of the square root of x cubed. Final answer. Okay, let's try another. Y equals x squared plus 2x plus 1 all over x. I'll split it up, x squared over x plus 2x over x plus 1 over x. Okay, so 2 take away 1 is 1, so it's going to be x to the 1x. Those two will cancel, that's just plus 2. And I'll bring that up, and that will be x to the minus 1. I can now differentiate. Differentiate x and you get 1, differentiate 2 and it vanishes. And that will be minus x to the minus 2. Tidy it up, and that is 1 minus 1 over x squared. Okay, let's try f of x equals 3x squared plus 4x plus 1 all divided by 4x squared. And split the thing up, so it's going to be 3x squared over 4x squared plus 4x over 4x squared plus 1 over 4x squared. Okay, so the x squareds cancel out there to leave me with 3/4. Remember that the power there is 1, even though it's not shown. So 1 take away 2 will be x to the minus 1, and the 4s will cancel out. I'll then bring that up, and that's 1/4 x to the minus 2. Okay, I can now differentiate. So 3/4 is a constant, so that becomes 0. That'll be minus x to the minus 2, and minus 2 times 1/4 is minus 2/4 x to the minus 3. So minus 2/4, I can simplify that. That'll be minus 1 over x squared minus 1/2 x to the minus 3. Finally bring that power down, minus 1 over x squared minus 1 over 2x cubed.